Okay, so welcome to the guided notes for 6.3. We're going to talk a little bit about the polynomial vocabulary, some factored form, and some sketches. So a couple of things that we need to kind of work on first is we need to understand exactly what standard form is, right? Now, standard form means we're going to decrease power. We're going to write it in order of decreasing power. So we can see here that the powers in the following polynomial here are 5, 3, we have 1, right? If there's no power there written there, we have a power of 1, okay? So what we're going to do here is we're going to write this in decreasing order. So the first number we're going to write is negative x to the 5th divided by 9. And the next thing we're going to write, there's no fourth power, so then we're going to write plus 10x to the 3rd power. There is no second power, and if you want, you can cross these off once you're done with them. And then the next one is the first power. So since it's a positive number, I'm going to write plus x. And I'm going to tack that number onto the n minus 3. And this is considered standard form because you can see right here, it is in decreasing order here. I've got 5th power, 3rd power, 1st power, and then the 0th power, or there is no power there, technically because it's 3 to the 1st power, okay? Right, so that's pretty simple, just decreasing powers here. Next thing we want to know is, let's take a look at the vocabulary. So some of the vocabulary words here are degree, and degree means the highest power, okay? And also represents the total number of possible real roots, okay? So linear would be anything to the 1st power, quadratic is 2nd power, which you should know already. Cubic is 3rd power, quartic is 4th power, and quintic is 5th power. So these represent all polynomials, okay? The leading coefficient is the number in front of the highest powers. That's why it's the leader. It's the leading coefficient. So that's the number in front of the highest power. And the last one is the constant, and the constant is just the number. There's no variable there. All right, so let's just take a look at one example of that and see how that works. If you want to rewrite this in standard form, you can, or you can just kind of go through it here and look at it first, all right? So the first thing we want to look at is this represents what is the highest power right there? It's the 5th power, so this would be a quintic polynomial. With how many terms do we have here? Well, terms we should know already, right? But terms represent things that are separated by addition or subtraction. So in this case, there are 1, 2, 3, 4 terms here. So you'd say this has 4 terms. The constant term is the number 4 here, right? The constant is the number that has no variable. So you would say 4, right? The leading term is the highest power. Right, so the leading term is going to be this one, even though it's not first here. If you've written it standard form, it would be the first term. So that would be negative x to the 5th. And then the coefficient will be the number in the front right there. So the number in the front right there is technically negative 1. Right, so that's how you're going to break down some of this vocabulary. Right, you want to be as familiar as you can with it so it's a little bit easier to communicate while we're working on it. Okay? Next step is determining equations of a line, right? So, or of a polynomial. So now we're just going to assume that the a value equals 1. We're going to talk a little bit more about that in the future here. But the a value here equals positive 1. So if we're going to write a function here, we're going to say, well, this is a function. This is f of x, right? This is going to be called f of x. And what we're going to do is we're going to write it in factored form, right? The first root that we have here is negative 4. Okay, so this is negative 4, right? The second root that we have here is 0. And then the third root that we have here is positive 5. Okay, so what you need to think about here is, first of all, let's do the easier ones first, right? So if we know negative 4 is a root, we know that x plus 4 needs to be a factor. And then if we know 5 is a root, we know that x minus 5 is a factor because that's what makes it equal to 0, right? That's really what we're looking at. We want to know, like, well, okay, so when does this become 0? All right, so when does it, whoops, sorry, when does this become 0? Okay, and the last one is 0. So now if it is just 0, what we're going to want to do here is we're going to write the 0 as the number x, right? So if I substitute x here into this equation, if I substitute 0 into the x, it makes the whole equation equal to 0. Okay, so you can see how each of these roots identify. This is the 0 root. Okay, then you've got -4 makes this 0, and then you've got +5 makes that 0. All right, so that's how we come up with an equation in factored form if we're kind of looking just right at the roots. You've already kind of seen this in with quadratics, okay? But let's move on to another example right here, because sometimes with a polynomial, you'll have what's known as a double root, right? So if I'm going to write this equation here, I'm going to say, well, I know this is a function of x, right? I can draw a vertical line anywhere I need, right here, here, here. It's all a function, okay? Now I'm going to look at the roots here. So I notice that 7 is a root, but if you notice, it doesn't go through 7. It bounces off 7. So what we're going to say here, it's going to say x minus 7 squared, because it bounces, right? So that if this is called a double root, okay, it bounces off of -7, right? And it should be a plus because we're looking at -7 plus 7 is equal to 0. So it's a double root there, right? So -7 goes in here, it'll equal 0. And this next one right here, we hit at +5, but notice how it goes through 5. It doesn't bounce off it, so we're only going to need one x minus 5. And then there you go. You can see that there are 3 roots to this. The degree is 3 because we have 2 x's in the first one and 1 x in the next one. Okay? Now this is all assuming that we have a positive a value. And what happens if we have a negative a value? Well, that's going to change the n behavior, right? The n behavior. So, for example, here, if we're just going to come up with an equation here, here are our roots. We know that we're looking at a function. So let's call this f of x, right? F of x is equal to. Now, if you notice that the n behavior is heading down to infinity in this direction and up to infinity in this direction. It's opposite. It's going up here and it's going down here. It's opposite from what it was over here. You can see the n behavior was heading up here and then n behavior is heading down here, okay? So that's what makes us know that we have a negative a value. So I'm going to tack on a negative right away in the front. Now again, we're assuming that the a value is equal to 1, so now let's just look at the roots. So I've got -1 is a root there, so I'm going to write x plus 1. And then I've got +1 is another root there, so I'm going to write x minus 1. And the last one all the way over here is 5 is our third root, so I'm going to write x minus 5. So there you go. It's as simple as it gets. That's an equation of a cubic, right? Because it's to the third power. There's 3 x's there, and it's negative since it's heading in the opposite direction of a positive version. Okay. All right, let's look at this one. Okay, so now this is upside down, right? You notice, remember, if a parabola, if you have a positive a value of a parabola, it would be like this. And then if you have a negative a value, it would be like this. So the same thing is true for this quartic equation, right? So this is really a unique one. I like this a lot. So I'm going to write this as f of x is equal to, and assuming where our a value is 1, notice how it's heading down. So right away, I'm going to say negative. And in this case, it's -2. So I'm going to write x plus 2. But again, notice it comes and it bounces off of it. So I'm going to square that, right? And it hits also +2 over here. Right, let me just change the color to keep it kind of set here with +2. So I'm going to write x minus 2. And notice how it bounces off. So it's a double root. So there you go. You've got negative x plus 2 quantity squared times x minus 2 quantity squared. Okay, so that's pulling from a graph. right? And now we want to take from a graph, or so from an equation, and sketch it on a graph, okay? So even though there are numbers on here, I'm still just going to sketch, right? I'm going to leave everything else to the imagination here, okay? So these numbers, they're not even there really, okay? Don't even worry about these numbers. Okay, now the x values we're going to look at. Look, so what number is going to make that 0? Well, -1 is going to make that 0. And then what is going to make this 0? Well, -4 is going to make that 0. And what number is going to work for here? Well, +5 is going to make that 0. Okay. Last thing we need to look at here is we need to understand that the a value here is positive. A equals +1, which means it's going to end up here and it's going to come from down here. Right? So it's going to go here, here, and then here. All right? So that's how you sketch. Okay, you just lay out the roots, figure out the end behavior, and then run it right through. Okay? Let me show you what it looks like with a negative a value. Okay, here in this factored form right here, we have a negative a value. So right away, I notice that a equals -1, which means it's going to end over here, all right? And then end over here. The end behavior is going to be headed in that direction, okay? So let's identify the roots. Well, first of all, we've got a -2, so right there. And then we've also have a -6, so I'm going to put that right there. And then we also have a +7, so I'm going to put that right there. Okay, so if I were to sketch this graph, it starts here, it's coming down, it comes back up, and then it's going to go back down, right? And again, we are ignoring these y values right now because we are just creating a sketch. Okay, so there you go. And then the factored form of a polynomial right there, that is a mathematical definition if you are interested in checking that out. Okay, hope this helps.